Hey, what is up guys? Welcome to another video. In this video I'll be going through grade 6 to 9 revision questions. These are from a gold test written by Edexcel and they're focused around assessment objective 3, which is to do with problem solving. If you want to have a go at these questions, I'll link the paper in the description so you can have a go and then come back and check your answers afterwards if you like. So let's get straight into it. The first question, question 1, says Pavel has a combination lock. Pavel has to set each part of the lock to a digit between 0 and 9 inclusive. One possible way to do this is shown in the diagram. How many different ways can Pavel do this? So in GCSEs, this topic is known as counting. You might think that's a confusing name because obviously counting, we're not just counting numbers. Oh, I can count from 1 to 10, but it's to do with counting the number of different combinations of something. Another name for this is combinatrix, if I can spell it right, which maybe is a more intuitive name, but I think in GCSEs they want us to use counting. So if we look at this lock, you can think of it as 4 different spaces, and in each space there's 10 different digits you can use. So you can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the first space here, there are 10 possibilities. Same for the second space, and the third and the fourth. So in each space we have 10 possibilities, and to find the total combination, we just need to multiply those together. If you're confused as to why we're multiplying, it might help to think of it as a tree perhaps. So in the first space we have 10 possibilities. So if I draw 10 branches, that's 10, and then each of those branches that has 10 possibilities, and this tree kind of branches out until we have, at the end, we have 10 times 10 times 10 times 10 possibilities. So a tree is one way to picture this, but we're multiplying all of the numbers to get the total possibilities and we get 10,000. Okay, the second part of this question says Pavel decides that the first and third digits will be odd numbers and the second and fourth digits will be even numbers greater than 0. How many different possibilities are there now? So let's have a look at our spaces again, and we're going to be multiplying them again. And the first and the third digits, they need to be odd numbers. So how many odd numbers are there between 0 and 9? Well, there's 1, 3, 5, 7, 9. So there's 5 possibilities there. So 5. The second and the fourth digits, they need to be even numbers greater than 0. So how many even numbers between 0 and 9? Well, there's 2, 4, 6, 8. So there's only 4 possibilities in those spaces. So what we can do is we can say, well, there's 5 here, 4 here, 5 here, and 4 here. And we multiply them all together. Well, 5 times 4, that's 20. So it's going to be 20. And then 5 times 4 is 20. So 20 times 20, that's 400 possibilities. So it really goes down with those limitations. The number of possibilities really drops considerably. Question 2 says C is the curve with equation y equals x squared minus 4x plus 4. L is the straight line with equation y equals 2x minus 4. L intersects C at 2 points A and B. Calculate the exact length of AB. So they've given us a curve, and this actually looks like a quadratic and a straight line, and they're saying the straight line cuts the quadratic. And because they've given us graphs, I immediately want to draw a sketch of this, so I have a picture of this in my mind. So even if it's not accurate, I want to draw a quick sketch just so I can picture what's going on. So let's see. So this is a quadratic, and it's a positive quadratic, so it must be going up this way somehow. It must be going facing up. And this is a straight line, and it has a positive slope, so it must be going this way somehow. So it might look something like this. Again, this might be completely wrong, but at least I kind of know what's happening, and then A might be here and then B might be here. So the line is cutting the curve at 2 points, and I need to find what those 2 points are in order to find the length of AB. So how can I find the points where the line cuts the curve? Well, that will be where the equations are equal, where the y values are equal. So I can say, so my starting point here is to let the equations of these lines equal each other. So I can say that x squared minus 4x plus 4 equals 2x minus 4. So where they cut will be where those two equations are equal. And then now we've got one unknown and one equation, so we can solve this for x. So the first thing I want to do is to combine all of the like terms. So I want to take this 2x and bring it over here, and then this minus 4 and also bring that over there. So to get this 2x on this side, I need to subtract it from the left-hand side. So I've got an x squared and then minus 4x minus 2x. That's going to be minus 6x. And then minus 4 plus 4. Sorry, plus 4 plus 4. That will be plus 8. And then because I've gotten rid of everything on this side, I'm just left with 0 on the right-hand side. So now I have a quadratic which I can factorize. And let's see if we can find two factors of 8 that make minus 6. Well, the two factors of 8 are 4 and 2. And if I subtract both of those, that will make minus 6. And minus 4 times minus 2, that's plus 8. So my two factors there are minus 4 and minus 2. So therefore I can factorize this into two brackets. And I put my x's in, and then I've got a minus 4 and a minus 2. Alright. Okay, so now I can say that x will either equal plus 4 or x will equal plus 2. Alright, so I've solved for x. I've found the two x coordinates of a and b, and now I need to find the y coordinates. Well, the way I can find the y coordinates is to substitute these x values into one of these equations. I'm going to pick the straight line equation because then I don't have to deal with an x squared. So I can say that using y equals 2x minus 4 when x equals 4, y will equal 2 times 4 minus 4. That's going to be 8 minus 4, which will equal 4. So that will be point A, or it could be point B, but let's just say that will be A. So A will be 4, 4. Alright, and then we need to find point B. So when x equals 2, y equals 2 times 2 minus 4, which is 4 minus 4, which is 0. So then point B equals 2, 0. So that's the x coordinate and that's the y coordinate. Alright, so I have my 2 points, A and B. And then to find the distance between 2 points when you're given coordinates, you need the distance formula. So the distance equals the square root, hopefully you've seen this before, the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's a derivative of the Pythagoras' theorem, because this length can actually be, it's essentially a right angled triangle where x is one leg and y is the other leg. But anyway, as long as you've used this distance formula before, you'll be fine. So now we just need to plug in the coordinates from the 2 points. So x2 here will be 4. So x2 is 4 and x1 is 2. And then y2 is 4 and y1 is 0. And then square those. So I've just plugged everything in. Now I need to go ahead and solve this. So this is going to be the square root of 4 minus 2, that's 2 squared, that's 4. And then 4 squared, that's 16. 4 minus 0 is 4, so 4 squared is 16. And then this will be 4 plus 16, which is 20, so this will be the square root of 20. And I'm going to leave it as that. So the distance between A and B is square root 20. So then, well, let's just finish off and say the length of AB is the square root of 20. And that's finished for 6 marks. So let's see where the marks go there. So I'd say the first couple of marks is to make those equations equal and solve for x. There'd be probably 2 marks there. 1 mark maybe for finding the y coordinates, or 1 mark each for finding the y coordinates, and then 2 marks for finding the distance. Okay, question 3 says, here is a solid bar made of metal. The bar is in the shape of a cuboid. The height of the bar is h centimeters. The base of the bar is a square of side d centimeters. The mass of the bar is m kilograms. And then they give us their measurements. So d is 8.3, correct to 1 decimal place. M is 13.91, correct to 2 decimal places. The height is 84, correct to the nearest whole number. And then it's asking us to find the value of the density of the metal to an appropriate degree of accuracy. Give your answer in grams per centimeters cubed. You must explain your answers to an appropriate degree of accuracy. This isn't just a simple density question, because they've given us, they've told us they're rounding off the numbers, and then they've asked us for an appropriate degree of accuracy. So the combination of rounding and asking for a degree of accuracy means we need to find upper and lower bounds. So this kind of adds an extra layer of complexity to this question. So we're talking about upper and lower bounds here. I'd say that's the main idea behind this question. Okay, so in order to find an appropriate degree of accuracy, we need the lowest possible density, or the lower bound of the density, and the upper bound of the density. And the way we can do that is to find the lower bounds of all of these measurements, and then find the density, and then the upper bounds of all of these measurements, and then find the density from those. Okay, so, well, firstly let's talk about how do we find the density. So the density is the mass divided by the volume. So how heavy something is divided by how much space it takes up. In order to get the upper bound of the density, we want the highest possible value for the mass and the lowest possible value for the volume. That's going to give us the highest possible value for the density. So the upper bound of the density will be the upper bound of the mass. So let's have a look at the value for mass. That's 13.91. So the upper bound of that is 13.915. And then we want the lower bounds of the volume. So the lower bound of D is 8.25, and the lower bound of the height is 83.5. So that's going to give me the upper bound of the density. So to work out the upper bound of the density, I can do the mass, and they want it in grams, so we need to convert this to grams. So all we need to do is multiply that by 1000. So that's going to be 13,915 divided by the volume, which is the area of the square times the height. So d squared, 8.25 squared, times the height, 83.5. And so that will give us, if we take the calculator out, that will give us 2.448. 2.448, which rounds off to 2.4. And then to work out the lower bound of the density, we want the lowest possible value for the mass. We want the lowest possible value for the mass and the highest possible value for the volume. So the lower bound of the mass will be 13.905. The upper bound for D will be 8.35, and the upper bound for H will be 84.5. And so the lower bound for the density will be, again, convert to grams, 13,905 divided by 8.35 squared times 84.5. Put that into a calculator. Let's see, 13,905 divided by, make sure you put some brackets in, 8.35 squared times 84.5, and you get 2.36. Okay, so that's the lower bound of the density, 2.36, and the upper bound was 2.448. So to one decimal place, this is going to be 2.4. 2.4. Why is it 2.4? Well, actually, let's rub this out for a sec and just say, what can we make sure that the density definitely is? Well, we can definitely say it's 2, because both answers have a 2. And we can say that it's 0.4 because both answers round to 2.4. We can't go to 2 decimal places because to 2 decimal places this is 2.45 and this is 2.36. So to 2 decimal places it would be wrong, 2.4 would be wrong, but to 1 decimal place it satisfies both the lower bound and the upper bound. So that's why 1 decimal place is an appropriate degree of accuracy, because both bounds round to 2.4. If this was, for example, if the lower bound was 2.34, that wouldn't round to 2.4, and the best degree of accuracy we could get there is actually just 2, because this would round to 2.4, this would round to 2.3, and we couldn't use the first decimal place. But because they both round to 2.4, we can use 1 decimal place. Question 4 says expand and simplify x bracket x plus 1 x minus 1. So all we need to do here is expand the double brackets using whichever method you prefer. I like to use FOIL. So firsts is x squared, outers is minus x, inners is plus x, and last is minus 1. And then that's going to be x times x squared. These cancel out, minus x plus x, they cancel out, and we're left with minus 1. And then if we expand those, that's going to be x cubed minus x. So that's for 2 marks. Second part of this question says, in a list of 3 consecutive positive integers, at least one of the numbers is even, and one of the numbers is a multiple of 3. So they're giving us a bit of information about 3 consecutive numbers. And then it says n is a positive integer greater than 1. And part B says prove that n cubed minus n is a multiple of 6 for all possible values of n. Alright, so a bit of information to take in there. If it's not immediately obvious, try to start connecting part A to part B. Why are these in the same question? Well, notice this n cubed minus n looks very similar to this x cubed minus x. And this came from x plus 1, x minus 1. This equation, this expression, if you look at it carefully, actually represents 3 consecutive numbers. Because if x, let's say x is 10, x plus 1, that would be 11, and x minus 1, that would be 9. So this expression represents 3 consecutive numbers. They've told us that any three consecutive numbers, one is even and one is a multiple of 3. So this expression also represents three consecutive numbers. And there's something you should also know about multiples of 6. So if something is a multiple of 6, it needs to be divisible by 2, and it needs to be divisible by 3 as well. So if something's divisible by 2 and divisible by 3, it is a multiple of 6. So they've told us that already. They've told us three consecutive integers, positive integers, has an even number and a multiple of 3. And this expression, if you look at it carefully, represents three consecutive numbers, and that simplifies to x cubed minus x, or n cubed minus n. So essentially they've given us all the information we need. We just need to really state this in some kind of answer. So the way I'd start off is to say that n cubed minus n equals n plus 1, n minus 1, and that's from part A. So you can say from part A, you can just say given, and then we can say that if a number is divisible by 2 and 3, it is a multiple of 6. So n cubed minus n must have, so it's a multiple of 6 as well. Okay, so if a number is divisible by 2 and 3 is a multiple of 6, n cubed minus n must have an even number and multiple of 3, so it is a multiple of 6. The last part of this question says 2 to the power 61 minus 1 is a prime number. Part C says explain why 2 to the power 61 plus 1 is a multiple of 3. Alright, so let's connect this to the rest of the question. So we're talking about consecutive numbers. They've told us that consecutive numbers must have an even number and a multiple of 3. So if this is a prime number, if 2 to the power 61 minus 1 is prime, the number after that must be 2 to the power 61, and then the number after 2 to the power 61 must be 2 to the power 61 plus 1. So these are three consecutive numbers, and we're told that this is prime. This one must be even because it's a power of 2. Any power of 2 is an even number. So, and because they're consecutive, we know one must be a multiple of 3, this one must be a multiple of 3. Alright, so it might be worthwhile to state that in a sentence as well. So as something like that. Okay, so a fair bit of explaining and writing in that question, but an interesting question to consider in terms of you've got prime numbers in there, you've got cubics, and you've got consecutive numbers. Interesting question. On to question 5 now. Question says the diagram shows triangle ABC. The area of the triangle ABC is k root 3 centimeters squared. Find the exact value of k. As soon as I saw this question, I thought, oh no, this is going to be a lot of working out, because if you look at this triangle here, they don't give us side lengths exactly, they give us expressions for lengths for each side. So this side is x plus 1, this side is 2x minus 1, and this side is x minus 1. So as soon as I saw that, I knew there's going to be a lot of algebraic working out. Now there's actually two formulas you need for this question. Pause the video and have a think. Which two formulas do you think you'll need to help with your working out in this question? Okay, the two formulas are the cosine rule and the sine rule for the area of a triangle. When you see this triangle, hopefully you start thinking cosine rule and sine rule because they give us one angle and these side lengths as algebraic expressions. And they also give us an area. Now the way we can connect side lengths of a triangle with area is using the sine rule. So that says that the area of a triangle equals half AB sine C, where the angle C is the angle between the two sides A and B. And the cosine rule, what that allows us to do is to solve for x, because it gives us an expression relating all of the sides together with the angle inside it as well. So the cosine rule says a squared, which is a side, equals b squared plus c squared minus 2 lots of bc cosine a. So they're the rules as they would be stated on the formula sheet. Just be careful because the variables in this rule might not exactly be related to the variables in this one. This is just how the formulas are usually written. So the reason I say that is because in this one it's cosine A and this one it's sine C, but actually I'm talking about the same angle. So if we use the cosine rule, we can relate all of these side lengths together along with this angle, and that's actually going to allow me to solve for x, because I'll have one equation with one unknown, and as long as I've got one equation for one unknown, I'm able to solve for that unknown. So the first thing I'm going to do is to find what x equals, and then I'll worry about this area stuff later. So let's get started on finding what x equals. So using this cosine rule, I can say that, let's say that, well, this has to be sine A because this relates to angle A. So side A must be opposite angle A. So in this formula, I need to use 2x minus 1 as A. So I'm going to say that 2x minus 1 squared, and I'm just taking these side lengths and plugging them into this formula. So 2x minus 1 squared equals a b squared, and either of these sides could be b. Let's just say that's x plus 1 squared plus c squared. So this is c, x minus 1 squared, minus 2 lots of bc. So b was x plus 1, c was x minus 1, and then cosine of 120. Now, the cosine of 120 is interesting because it's actually the same as, or almost the same as, the cosine of 60. And hopefully you have memorized the cosine of 60. It's one of the values you need to know for the GCSEs. One way to remember it is to remember these little triangles, these little right angle triangles, where one angle is 30, the other is 60, and the sides of this triangle are 1, 2, root 3. So if you can remember this triangle, you can remember that the cosine of 60 is the adjacent side over the hypotenuse. So the cosine of 60 is a half. Now the cosine of 120 is the same as the cosine of 60. I won't get into why that's the case just now because I think that's a more detailed topic, but it's actually the negative of cosine of 60. So this is going to be minus a half. And if you didn't know that, you could always just put it into your calculator and that would give you minus a half. So now we have an equation relating all of the unknowns together, and we can go ahead and solve this equation for x. And you can see there's going to be a lot of simplifying. So let's start on the left hand side, 2x minus 1 squared. If we expand those brackets out, we'll get 4x squared minus 4x plus 1. So you can't just square everything inside the brackets. This is actually essentially 2x minus 1 times 2x minus 1. And then you need to use a method to expand the double brackets. So I've gone ahead and done that, and then I need to do the same for these brackets in here that are squared. So that's going to be x squared plus 2x plus 1 plus, now I need to square this one, 2x, oops, not 2x, x squared minus 2x plus 1, and then minus 2, and then I need to expand these double brackets out as well. So that's just going to be x squared minus 1, because the x's in the middle cancel out. And then the cosine of 120 I said was minus a half. Alright, so I'm going to leave the left hand side as it is at the moment, and then just worry about this right hand side. So I might go ahead and cross things out as I write them down. So let's combine some like terms. So I've got an x squared and an x squared here, so that's going to be 2 lots of x squared. So I've used those up, and then I've got a 2x and a minus 2x, so they cancel each other out, don't have to worry about those anymore. Then I've got a plus 1 and a plus 1 here, so that's going to make plus 2. And then over here, because these are all multiplied together, this minus a half cancels out this minus 2. So this over here, this just becomes plus x squared minus 1. So what I'm saying there is that minus 2 multiplied by minus a half, that just equals plus 1. So that all becomes a positive. Alright, so now let's simplify that a bit more. So that's going to be 4x squared minus 4x plus 1 equals 2x plus x squared, that's 3x squared, and then 2 minus 1, that's plus 1. Alright, almost there. And now we need to combine all of the like terms on the left hand side. So we can subtract that 3x squared from this side. So 4x squared minus 3x squared, that's going to be x squared. And then I've got a minus 4x, and then this plus 1 minus 1 from this side, that's going to be 0. So we're left with x squared minus 4x equals 0. So therefore x, and then I can factorize an x out. So this is going to be x bracket x minus 4 equals 0. So therefore x could equal 0, or x could equal 4, because one of these two things has to equal 0. So if x minus 4 equals 0, x equals 4. Now let's just go back to the diagram quickly. If x equals 0, what would happen? If x equals 0, this would be negative 1. And because it's a length, it doesn't make sense for it to be negative. So x can't equal 0, so therefore x must equal 4. Okay, and so now we have a value for x. Now we have a value for x. We know all of the side lengths, and we can use this area formula to to relate this to k. So we can say if the area is, let's just write this out again. It never hurts to write formulas out more than once. It's good for memorization. So the area equals half AB sine C. Now, because I'm using this angle as sine C, these two sides must be A and B. They must be the sides opposite of the angle. Let's just work these out. Because x equals 4, remember, so this side must be 5 centimeters and this side must be 3. So I get half 3 times 5 times sine of 120. Now similarly to how cosine of 60 equals the negative of cosine 120, the sine of, if we work out the sine of 60, it's actually root 3 on 2, so the opposite over hypotenuse, and the sine of 120 is actually the same. It's not a negative of that. The idea is that the sine of something represents the y value and the cosine represents the x value, and if you think about quadrants in a circle, then the value for the y value doesn't change. But I won't get too deep into that. I might do an extra video on that because that's, it takes a while to explain that. But anyway, you could always, as I said, put that into a calculator and you would get root 3 on 2. So the sine of 120 is root 3 on 2. So this is going to be 15 on 2 times root 3 on 2. And then we can multiply everything essentially. So this is going to be 15 root 3 on 4. And what they're asking here, they've told us the area equals k root 3 centimeters squared. So in this case, well, we've got the root 3, so k must be 15 on 4. And that is a 7-mark question. So, well, you had to recognize the formulas. You had to know the absolute values of cosine and sine of 120. You had to do all of this algebraic working out, and then you had to relate the area to the sine rule. So a good 7 marks involved there. Question 6 says, Alfred studies animal populations on an island. The size of an animal population at the start of 2014 was 2,500. The size of this animal population increases exponentially. Alfred assumes that the rate of increase is 20% per year. Part A says, using his assumption, work out the size of this animal population at the start of 2009. Okay, so it's increasing by 20% per year. So if we take the population from 2009, so this means population in 2009, and we multiply it by 1.2, that would increase it by 20%. And we're doing that for 5 years, so we need to raise that to the power of 5. And then if we multiply the population in 2009 by 1.25 times, we'll get the population in 2014, which is 2,500. It says it in the question. So if we want to work out the population in 2009, we can divide 2,500 by this number, 1.2 to the power of 5. And now I'll get out my fancy calculator app that I've downloaded for these videos. And I'll do 2,500 divided by, and I might just use some brackets just to be safe, 1.2 to the power of 5, and brackets. Probably don't need those brackets, but sometimes it just helps. And I get an answer of 1004.693. So 1004.693. And because we're talking about a population of animals, we don't really want to leave it as 0.69 of an animal, so we should round that up to 1005 for the population in 2009. Okay, part B says Alfred's assumption is too high. Explain how your answer to part A is affected. So Alfred's assumption was that the rate increases by 20% per year, and that's too high, so it's actually going to be lower than that. So in that case, this denominator here, what we've divided by, that would actually go down, and if you decrease the denominator of a fraction, well, think about this example, so 10 divided by 5 is 2, and then if I decrease that number, 10 divided by 2 is 5. So if this number goes down, this number goes up. So the population in 2009 would be higher than 1005. So we can say the population in 2009 would be greater. Okay, that was question 6 for 4 marks. Question 7 says a rectangular sheet of paper can be cut into 2 identical rectangular pieces in 2 different ways. When the original sheet of paper is cut one way, the perimeter of each of the 2 pieces is 50 centimeters. When the original sheet of paper is cut the other way, the perimeter of each of the 2 pieces is 64 centimeters. what is the perimeter of the original sheet of paper? Right, so we need to relate the lengths of this original sheet to these shapes here. So this was the original piece of paper, and I've cut it in half long ways to get these two shapes, and then I've cut it in half this way to get these two. And it said when the original sheet of paper is cut one way, the perimeter of each of the two pieces is 50 centimeters. So the perimeter of this shape would be 50, or it could be this one. It doesn't really matter, you're still going to get the same answer because we'll work it out algebraically. And then the perimeter of this shape here would be 64. Okay, so let's look at this original sheet of paper, and let's call this length x and this length y. And what we're actually going to have to produce here is a set of simultaneous equations. So because we're given two values. So what would if this is x and this is y, what would the perimeter of this shape be? Pause the video for a sec, see if you can figure it out. So if this length is y, the perimeter would be 2 lots of y, and then this is going to be a half x, and this will be a half x. So it's going to be 2 lots of y plus 1 lot of x to get the perimeter, and that equals 50. Okay, down here, try again, see what you think the perimeter of this shape will be. So we've got 2 lots of x, and then half y plus half y, that would be 1 lot of y equals 64. So we've got a set of simultaneous equations now, and we're going to have to solve for x or y. So let's write these down here now. So 2y plus x equals 50, and 2x plus y equals 64. Alright, I'm going to multiply one of these by 2, and I'm going to pick this one just because it's easier to multiply 50 by 2. So what I get is 4y plus 2x equals 100. So I've multiplied that whole equation by 2, and I'm leaving that one as it is, so that's going to be y plus 2x equals 64. I've just rearranged it so the x's are above each other, and then I can subtract those equations. So I get 3 lots of y and 2x minus 2x, that cancels out. So, and then I need to do 100 minus 64, and that gives me an answer of 36. So then 3 lots of y is 36, so therefore y equals 12. Okay, so then I can substitute that back into one of these equations to figure out what x equals. And I'll just pick this one, so I can say using 2y plus x equals 50, when y equals 12, 2 lots of 12 plus x equals 50. So therefore x equals 2 lots of 12, that's 24, so x will be 50 minus 24, so x will equal 26. Alright, so now I know on my original sheet of paper the dimensions. X was 26 and y was 12. You can see that maybe I got these equations arranged the wrong way around, because I've called this length x and that's longer than y, but it still doesn't really matter because I'm still going to get the same perimeter in the end. If they asked for the dimensions, maybe I would have had to be more careful, but because they've just asked for the total perimeter, it doesn't really matter which way around the variables are. So now I need to work out the total perimeter. So I just need to do 2 lots of x, 2 lots of 26, plus 2 lots of y. So that's going to be 52 plus 24. 52 plus 24, that's 76 centimeters for 5 marks there. Question 8 says the quantity of heat, H calories, delivered by an electric current, I amps, acting for T seconds to heat an amount of water is given by the formula H equals AT I squared minus B, where A and B are constants. Rearrange the formula to make I the subject. Okay, so first thing we need to do is to get rid of this B on this side because that's a negative, so we need to add that to the other side. So my first line of working is just going to be AT I squared equals H plus B. All I've done is flip it around so the I's on the left, and I've added that minus B to the left hand side. And then I want to divide this AT over this side, so I get I squared equals H plus B divided by AT. And then I need to get rid of this square. So I'm doing the opposite of BIDMAS here. I'm doing the negative and then the division and then the exponent. So therefore I is going to equal the square root of H plus B over AT. And then I've made I the subject. Second part of this question says the graph gives information about the variation in the temperature in degrees of an amount of water that is allowed to cool from 80 degrees centigrade. Okay, so it started at 80 degrees and it's cooled down. What's it cooled down to? So if this is 20, that must be 30 there. And what are we going up by? We're going up by 2, 4, 6. So each line is 2 degrees. So this temperature here must be 32. So it's cooled down from 80 to 32 degrees. And part B says work out the average rate of decrease of the temperature of water between T equals 0 and T equals 800 seconds. Okay. So to work out the average decrease, we need the total decrease in temperature divided by the time it took. So the total decrease was from 80 to 32, so that's 48 degrees divided by 800 seconds, they've told us that. And then if we divide both of those by, well, you can do it a number of ways, but actually if you divide both by 16, you get 3 over 50 degrees per second. And maybe it makes sense to change that to a decimal because we're talking about degrees. So that's going to be 0.06 degrees per second. Okay, so on average every second it's decreasing 0.6 degrees. Okay, the next part of this question says the instantaneous rate of decrease of the temperature of the water at time t seconds is equal to the average rate of decrease of the temperature of the water between t equals 0 and t equals 800. Find an estimate for the value of t. You must show how you got to your answer. So this is saying there's some time t where the rate of decrease equals the average rate of decrease. So at some point on this graph, the water is cooling down at the exact same rate as the total average. So the way in GCSEs, the way that you find the instantaneous decrease of a graph is to find the slope at that point. What we can do is we can find a point on this graph where the slope equals 0.06 or 3 over 50, and that will be the point where the instantaneous rate of decrease equals the average decrease. So let's go back to the graph now, and let's try to draw a line where it has a slope of 3 over 50, or actually it's going to be negative 3 over 50 because it's decreasing. Let's have a look at the y-axis firstly. So if we go from 0 to 30, let's say this was my rise here. What would the run have to be to make this equal 3 over 50? That would have to be, well, if the rise, remember the gradient is the rise over run, so if the rise is 30, then we need to multiply that by 10 as well, so that's going to be 500. So the slope, the slope or the gradient of the line representing this rate of decrease will look like this. And 500, hang on, let's zoom in a little bit. 500 is where? 500 is there, yes, got that right. So just to help us picture this a little bit, the gradient of this line represents the average rate of decrease. Hopefully you can see that because the rise over the run equals 3 over 50, which was our average rate of decrease. So that line is representing that, and then we can look for a spot on this graph where the slope equals this line. One way I might do this in an exam would be to draw this line first, and then maybe get your ruler. So a ruler has a certain width, and then try to draw some parallel lines until one touches the graph. What I'm going to do is I'm going to cheat a little bit here because I have this program. I'm going to select this line and move it up. But you could do the exact same thing with the ruler on it with a pen and paper. So if I move this line up here, you can see it clearly doesn't represent the slope if I move it down here. And it doesn't represent the slope if I move it up here somewhere. But somewhere around this point, you can see how the slope of the line matches the slope of the graph. And it starts to go off a little bit when I move down. So if I leave the line, let me zoom in a bit again. If I leave the line somewhere around here, you can see it really gets close to the slope of the graph. And I would say it's about there. So, and clearly it's touching at a number of points. Let's try to find some limits of where this might belong. So if this is 300 down here, let's go up to the graph. It could be around 300. If this is 400, it's clearly in there somewhere because here there's a bit of a gap and here there's a bit of a gap, so it's somewhere in there. If we really have a close look, really the midpoint of that is where it's really closest to the slope of the graph. So my answer there is going to be 350. Now I think I had a look at the mark scheme and I think they were a bit mean because the range of answers here was given as 340 to 360. And I think it's pretty hard to get that degree of accuracy with questions like this, but maybe if this was on a printed exam, it might be easier. I'm not sure. Maybe just because this is a PDF, it's making it a bit more difficult to see. But anyway, my answer there is t equals 350 seconds. And I can say that that's the gradient. So my reasoning there is the gradient of the curve matches the average rate of decrease. Okay, on to question 9. Question 9 says, here's a spinner. When the arrow is spun once, a 1 or a 2 or a 3 can be scored. Bill is going to spin the arrow twice. He will work out his total score by adding the 2 scores he gets on the 2 spins. The probability that he will get a total score of 4 is 16 over 81. Assuming that the thickness of the 3 lines between the sectors may be ignored, work out the value of x. Okay, so this is our spinner, and the x is in here. This is the angle of the sector where the 1 is, and 2x is the angle of the sector where the 2 is. And we need to work out what x equals. And he's spun it twice, and he's got 4 by adding up the scores. So firstly, let's think about how he could have got 4 by spinning this spinner. Let's think of the possibilities. Well, on the first spin, he could get 1, 2, or 3. And on the second spin, he could get 1, 2, or 3. So if you think about your learning of combinations and counting, you know that there's 9 possibilities of the 2 spins. So actually, let's have a look at what those possibilities are. So he could get a 1 on the first spin, and then a 1 on the second spin. He could get a 1 on the first spin and a 2, and a 1 and a 3. Then he could get a 2 on the first spin and then a 1, a 2, and then a 2, and then a 2, then a 3. And then he could get a 3 on the first spin and then a 1 or a 3, then a 2 or a 3, then a 3. Okay, so there are all his possible spins. And he added the scores, so let's add these ones. So you get a 2 or 3 or 4, 3 or 4 or 5, and then 4 or 5 or 6. And he said his total is 4, so we are only interested in these ones here, where you got a 1 and a 3, or a 2 and then a 2, or a 3 and then a 1. Okay, so, and he said the probability of those things happening is 16 over 81. Right, now let's talk about how to represent these probabilities in terms of this spinner. Well, let's look at the probability of scoring a 1. Well, on a spinner, the fraction of the circle that represents the 1 is this angle. And how do we measure circles? We measure them in degrees, and there are 360 degrees in a circle. So the chances of spinning a 1 will be the angle of that sector divided by 360. And then the probability of a 2, well, that's going to be the angle again divided by 360. And then the probability of a 3 will be this angle divided by 360. They haven't given this angle, but we need to relate it to x, so we can say that this is going to be 360 minus whatever these angles are. So if we add these up, that's going to be 3x. So the angle of sector that belongs to 3 is 360 minus 3x. So the probability of spinning a 3 is 360 minus 3x over 360. Right. So now I know the probabilities of spinning those three things. And I've said that the only ones we're interested in is spinning a 1 and a 3, or a 2 and a 2, or a 3 and a 1. So let's work out the probability of scoring a 1 and then a 3. So the probability of scoring a 1 and a 3 will be the probability of rolling a 1, spinning a 1, which is x over 360, multiplied by the probability of 3. So in probability, when we've got two events and we use the word and, so 1 and 3 happen, we multiply them. And then the probability of the 3 was 360 minus 3x over 360. So that's the probability of 1 and then a 3. And actually, this will be the same as a 3 and then a 1. You'll get the same result. So that will be the same. And then the probability of a 2 and then a 2, that's going to be the probability of a 2 multiplied by itself. So 2x over 360 multiplied by 2x over 360. Okay, so let's work this one out first. We need to multiply everything. So x times 360 minus 3x, that's going to be 360x minus 3x squared. And 360 times 360, let's get the old calculator out again. Hopefully this looks pretty similar to your calculator. It might not be exactly the same, but hopefully it's pretty similar. 360 times 360, that's going to be 129,600. Okay, so that's the probability of a 1 and a 3, and the probability of a 3 and a 1 will be the same. And then the probability of a 2 and a 2, that's going to be 2x times 2x, that's 4x squared over, well, that's going to be the same number, 129,600. And now what we need to work out is the probability of 1 and a 3, or the probability of 3 and a 1, or the probability of a 2 and a 2. And when we're using or, we add. So we need to take the probability of a 1 and a 3, add it to itself essentially again, and then add the probability of a 2 and a 2. Okay, and we can work that out. So I'm just going to bring that over here, and then we need to add all of these fractions together. Because they've all got the same denominator, it's not too difficult. So 360 plus 360, that's 720x, and then minus 3x plus 4x. So that's going to be minus 6x plus 4, essentially minus 6 plus 4, that's going to be minus 2x squared, all over 129,600. Okay, so why have I done all of that? It's because they've told us that the probability of getting a 4 is 16 over 81. So I've worked out this in relation to x, and this is going to allow me to solve for x. So probability of 1 and a 3, or 3 and a 1, or 2 and a 2 was 720x minus 2x squared over 129,600. And all of this equaled 16 over 81. And then I can go ahead and solve for x. Okay, so let's get a calculator out again and work out 129,600 multiplied by 16 divided by 81 to get rid of these fractions. So I need to multiply this over here. Okay, so 129,600 multiplied by 16 divided by 81. Fingers crossed it's a nice whole number. And yes, it is. So we get 25,600. So we can say that 720x minus 2x squared equals 25,600. And hopefully you notice a common factor here. It's 2, so we can divide all of this by 2. So we get 360x minus x squared equals the answer. What's the answer divided by 2? 12,800. And then let's simplify this a little bit more, so to get it in the form of a quadratic equal to 0. So we'll get minus x squared plus 360x, and then take that from this side, so that's going to be minus 12,800 equals 0. Alright, so now I have a quadratic that I can solve for x. So I've reduced this whole problem down to a simple quadratic, which I can now solve. One other thing I could do is divide everything by minus 1. So when something equals 0, you can change all of the signs simultaneously, and that's just going to make it a little bit easier to solve. So this can change to plus x squared minus 360x plus 12,800 equals 0. And now we need to try to factorize this. Let's make it a little bit easier for ourselves. Instead of looking for the factors of 12,800, let's look for the factors of 128. So 128 could be 2 times 64, 3 doesn't go, 4 times 32, I've just halved that and doubled that, and I've just noticed something. Have you noticed it as well? 4 and 32, that makes 36, and I'm looking for 360. So how can we relate these factors to 12,800 and 360? Well, if 4 times 32 is 128, 40 times 320, that will make 12,800. I've just added 2 zeros on the end. And we need to make minus 360, so minus 320 minus 40, that will be minus 360. Okay, so I've found my two factors, and I can go ahead and factorize this into two brackets, which is great. So I don't have to use the quadratic formula, which would be a real pain to use with these numbers. So the first terms in these brackets are x, there's no coefficient of x here, and then in the first one I can do minus 40 and then minus 320. Alright, so now I can find the values of x. I'm just going to bring this over here because I'm running out of space. So x minus 40 equals 0, so therefore x would equal 40, or x could equal 320. So I've got two values of x. Well, go back to the question and see which one's realistic. So if x equaled 320, what would this angle be? This would be 2 times 320, which would be 640. That angle clearly can't be 640. It has to be less than 360. So the only reasonable answer for x is x equals 40 for this question. So that's my final answer here, and I guess that's in degrees, so x equals 40 degrees. And that's a 5-mark question. Quite a lot of working out there. You had to work out the probabilities of each number, and then you had to add them up, and then you had to factorize a quadratic. So fair bit of work there. So that's all the questions I'm going through in this video. I hope you found this useful. I thought they were pretty interesting questions. Some quite challenging ones in there, I hope. I hope you felt you were challenged by those questions. I hope you found this useful. Please leave a like if you did. Subscribe if you want to see more content, and I'll see you in the next one. Bye for now.